Fractional part integration from IIT JEE. So there's a pretty standard way to deal with these fractional part integrations. Basically, you dissolve this fractional part of x into x minus g of x. Yeah, and just that. You just use this property and deal with these integrals. Yeah. So let's begin. We have integral from 1 to infinity, fractional part of x by x to the power 4 dx. So you can do this, yeah, x minus fractional part of x. Now that this fractional part just increases in discrete amount, let's say for 1.2 it's just 1, and until it gets to 2 it's just 1, you know? So it's kind of discrete, it isn't continuous, and it's kind of like this. Yeah, so that's why this can be changed into sum, and that's really helpful. So we can change it to like this: sum from n equals to 1 to infinity, integral from n to n plus 1, x minus n by x to the power 4 dx. Here we are basically utilizing this discrete property of the g function, greatest integer function. So we have, this is just same. If we did, even if we didn't have n over here, this just implies that we are integrating from 1 to 2, 2 to 3, 3 to 4. That's just summation property of integrals, and we could have here n due to the discreteness. So it's really useful to be able to use this property. And now next is just to do integration. We have sum from n equals to 1 to infinity, integral from n to n plus 1, x to the power minus 3 minus n times x to the power minus 4 dx. Yeah. We will integrate sum from n equals to 1 to infinity, x to the power minus 2 by minus 2 minus n times x to the power minus 3 by minus 3 from n to n plus 1. Now sum from n equals to 1 to infinity, this is minus 1 by 2 times n plus 1 all square, and this is plus 1 by 3. Let's just make them plus. Plus 1 by 3 times n plus 1 cube, and also we have n over here, 1 dot n, yeah, and then minus, oh yeah, and again there is minus, so plus 1 by 2 times n square, and oh yeah, this is minus, so the minus, and n by 3 times n cube. Is it? Yes, it is. Yeah. And now of course this will involve in cancellation, so we can use telescoping sum over here, and we can also manipulate these two to get telescoping sum. Okay, so let's do that. Sum from n equals to 1 to infinity, that is 1 by 2n square minus 1 by 2 times n plus 1 whole square, and this is, we can do n plus 1 minus 1, and so this will break to first let's write this one, minus 1 by 3n square, and then this is plus 1 by 3 times n plus 1 whole square, yeah, and then we have minus 1 by 3 times n plus 1 cube. Okay, so we have that, and now these two also involve telescoping sum, these two also involve telescoping sum. So basically, except the first term, all of those terms are going to cancel. You can see that. Yeah. So the first term 1 by 2 will be there, and 1 by minus 1 by 3 will be there. And from here we will have minus 1. Yeah, let's just write this on. We will have minus 1 by 3 times this will be 2 square, and then yeah, when it's 1 it's just, sorry, 2 cube, not 2 square, 2 cube, and then it's 2, it's 3 cube. 1 by 3 times 3 cube, and 1 by 4 times 4 cube, and so on. Yeah. Now I think we can take 1 by 3 common from both of them. So we get 1 by 2 minus 1 by 3 common. We will have 1 plus 1 by 2 cube plus 1 by 3 cube plus 1 by 4 cube, and so on. Let's also make this 1 by 1 cube. Now you probably know that this is the Riemann zeta function of 3. The Riemann zeta function of n is this inverse sum, and all of the denominator is to n. So that is 1 by 2 minus 1 by 3 Riemann zeta of 3, which is a Paris constant. So this is the answer, I guess. Yes, that's the answer, and we have solved this integral easily. Basically, the journey was really beautiful, changing the zip into n, knowing that it's a discrete quantity, and then looking for a telescoping sum, manipulating to get a telescoping sum, and then noticing that it's kind of zip function, taking common, making a complete, sorry, it's a zeta function and taking common and making a complete zeta function and getting a Paris constant. That was really beautiful. I hope you enjoyed this integral, and if yes, do like, share with your friends, and subscribe to get such content. Thanks for watching.